We are in section 2.3, graphs that enlighten and graphs that deceive. This goes through a bunch of different kinds of graphs that you're going to need to study and know how to create. The first one that we have is called a dot plot. This is a graphical display of data using dots. Each dot represents one observation and are stacked in columns over a category, so that the height of the column represents the frequency or the relative frequency. Dot plot is limited in usefulness, however, provides a quick picture of the data. So the first example that we have says Miss Harper's AP Calculus class has 14 students. The scores for the last exam are listed below. Create a dot plot for the data. And so the exams are here. The lowest exam score that we have is 64, and the highest one that we have is 96. So I'm going to go ahead and draw a straight line here. It needs to be a horizontal line. And I'm going to go ahead and start it at 60. And we're going to have to go all the way out till 96. So if you go out to 65, and then to 70, and so on. We're going to keep doing this. Once you have your axes drawn, we're going to go ahead and label it as what we're talking about. And for this is AP Calculus scores for their last exam. So I'm going to go ahead and put exam scores. We should be labeling stuff so that way you know and you're explaining what it is that you are portraying in your graph clearly. And so from here, we're just going to go ahead and look at our data set. First number that we have is a 77. So find 77 on your graph, and you're just going to put a dot hovering above 77. Next number we have is 85, then 73, 64, 90, 80, 81, 84, 96, 66, 77, which we already have a dot at 77. So we just go ahead and put that second dot right above it. And then we have 79, 70, and 82. So it just gives you a quick observation of the scores and how they are kind of spread out. The next type of graph that we have is called a stem plot or a stem leaf plot. It is another way to represent quantitative data graphically. We use the digits to the left of the rightmost digit to form a stem, and each rightmost digit forms a leaf. For example, 147 has a stem of 14 and a leaf of 7. Or 12.3 has a stem of 12 and a leaf of 3. So the next example is the same data set. It says Miss Harper's AP Calculus class has 14 students. The scores on the last exam are listed below. Create a stem plot or a stem leaf plot for the data. And again, these scores that we saw were in the 60s, 70s, 80s, and 90s. So first thing I'm going to do is go ahead and draw a vertical line down. And this vertical line separates my stems from my leaves. And from here we have grades in the 60s, in the 70s, in the 80s, and in the 90s. I'm going to zoom in a little bit here. And the only scores that we have that are in the 60s are 64 and 66. And so since I already have the 6 listed for 60s, I'm just looking at that second digit, which is a 4 and a 6. I'm going to put them in order. The smallest one we have is a 4. Next largest one we have is a 6. You do not use commas, they're just spaced between them. The next thing that we have is our 70s. And so with the 70s, we're going to go ahead and look at those. We have a 77, 73, 79, 77. So the first one that we have is a 70, so I'm going to put a 0. Then we have a 73. Then we have 77, 77, and 79. So I have 2 7s. And then a 79. So I'll put a 9 here. And then we're going to go ahead and look at the 80s. We have an 80. We have an 81. We have an 82. We have an 84 and an 85. Then we have a 90. We only have a 90 and a 96. So this is another way to represent your data. Kind of allows you to see the distribution of the data. This looks almost kind of bell-shaped. The next type of graph that we have is a time series plot. It is obtained by plotting the time in which a variable is measured on the horizontal axis and the corresponding value of the variable on the vertical axis. Line segments are then drawn, connecting the points. So we are going to connect those points. So the next example says the data below represents the annual total inches of rainfall in LA over a 5-year period. Use the data to construct a time series plot. So constructing our graph, we have a vertical axis, which for this problem is going to represent annual rainfall in inches, and a horizontal axis, which is going to be our time. And then our time is in years, but I want you guys to realize that the first year that we have is 2008. So I'm going to go ahead and put 08 here. And then the next one we have is 2009, 2010, 2011, and our last year is 2012. And again, this is years for our time. Our vertical axis is going to be talking about the annual rainfall that we have in inches. So I'm going to go ahead and label that. So annual rainfall. And we are measuring this in inches. So it's a good idea to label to clearly explain what it is that your graph is representing. And we look at our inches, the smallest value that we have is 8.69, and the largest value that we have is 20.20. So I need to make sure that I'm going all the way up to 20, a little over 20 inches. I'm going to count by fives. So 5 inches, 10, 15, and then 20. So from here, I'm just going to go ahead and plot a point for each of these years. So in 2008, the rain was 13.53. Do the best that you can. 2009 is a little bit less. This is at 9.08. In 2010, it was 16.36. And 2011, we had 20.20. And then in 2012, we had 8.69, so the smallest of our values. From here, we're going to connect these in order with straight lines. Do the best you can. And this is our time series plot. Again, check to make sure that your axes are labeled. The next graph that we have is our bar graph, and this is constructed by labeling each category of data, our qualitative data, on either the horizontal or vertical axes and the frequency or relative frequency of the category on the other axes. Rectangles of equal width are drawn for each category. The height or length of each rectangle represents the category's frequency or relative frequencies. So the next example that we have says an 8th grade teacher has 20 students in her science class. The final grades for those 20 students are listed. And it says create a frequency distribution. On this problem, there is a tally column there. Some students like to use this. It kind of allows them to tally things up, makes it easier to count, make sure they didn't miss anybody. And if you were to do that, you can just go ahead and go through these and go, oh, an A minus, a C plus, and tally them up, and then it makes it easier to count. I'm going to go ahead and cross it off for right now, and I'll leave that up to you guys to do if you want to. The frequency, the number of A's that we have. So if you were to count this, there are 2 A's. We have 3 A minuses. We have 1 B plus. 2 B's, 3 B minuses, 5 C pluses, 3 C's, no C minuses, so I'm going to put a 0, and we have 1 D. Adding these numbers up, we do get a total of 20, which is how many students we had in this class. So this one says to create a frequency distribution and a frequency bar graph of the data. So we already created our frequency distribution. And now we're going to go ahead and do our frequency bar graph. So go ahead and put a vertical line and a horizontal line. Our horizontal line is going to be our grades. So I'm going to go ahead and put lines on here for each of these. So we have an A minus, a B plus, a B minus, a C plus, a C minus, and a D. And these are our grades, so go ahead and label that. On the vertical axes, we are going to go ahead and put our frequencies in because it's asking for a frequency bar graph. So put frequency. And the frequencies that we have, the smallest value we have is a 0. And this goes up to our largest frequency, which is a 5. So I'm just going to count by ones. And from here, we're going to make bars. And so the first one that we have is A's. We have 2 of those. And we're going to have a space with bar graphs. Your bars do not touch. And so we have 3 A minuses. And your bar should be similar widths. 1 B plus. They should be the same width, however, it's difficult to draw that way. We have 2 B's. 3 B minuses. We have 5 C pluses. We have 3 C's. C minus, we just leave blank. And then we have 1 D. So again, check to make sure that you labeled your axes on your bar graph. The next definition that we have is called a Pareto chart. This is a bar graph whose bars are drawn in descending order of frequencies or relative frequencies. The bars decrease in height from left to right. The next example that we have deals with a pie chart. And a pie chart is a circle divided into sections. Each section represents a category of data. The area of each sector is proportional to the frequencies of the category. And circle that next example. We'll work on that in class together. Then we have what's called a frequency polygon. And this is a graph that uses points connected by line segments to represent frequencies for the classes. It's constructed by using class midpoints and heights equal to the frequency. And so when we do these graphs, we're going to be using midpoints, and then we're also going to be using frequencies. And it says frequency polygons provide the same information as a histogram. Then we also have a relative frequency polygon. This is a graph that uses points connected by line segments to represent the relative frequency for the classes. It's constructed by using class midpoints at a height equal to the relative frequency. So very similar. So we're still going to have our midpoints, but this time we're going to be using our relative frequencies. And then for both of these, so this is for relative frequency polygons and then also for frequency polygons, we're going to extend the ends of the graph on the left and on the right so that the graph starts on the horizontal line. So we will extend the ends of the graph on the left and on the right so that the graph starts on the horizontal line. The next definition we have is group data. We've actually seen this before, and this is formed by putting individuals' observations of a variable into groups. And then we have our midpoint definition, which is where we're going to take our upper class limit and our lower class limit, and we're going to add those together, and we are going to divide by 2. And again, we saw that earlier in this chapter. So we have an example here that says monthly rain totals in inches are represented in the table. Construct a frequency polygon of the data. So for our polygons, we need to actually calculate the midpoints. And if you notice, we are dealing with grouped data. The class for the first class that we have is 2.01 to 2.75. And again, we're dealing with inches of rain. And so what we need to do is go ahead and calculate the midpoint. So to do that, you're going to take 2.01, add together 2.75, and then divide by 2. For the first midpoint, you should get 2.38. And go ahead and do that for the rest of your class limits. So I have listed all the midpoints that we have for all of our classes for the monthly rain totals. From here, we're going to make our frequency polygon. And I want you guys to remember that we do have to draw lines for polygons to extend down on the left and the right side to the horizontal axes. So I'm going to keep that in consideration as I'm going to go ahead and build my polygon. So I have a vertical axis, and I'm going to have a horizontal axis. My vertical is going to talk about the frequencies. And so the smallest frequency that we have is 1, and this goes all the way up to 11. So I am going to count by ones. And then I'm going to have on my horizontal monthly rain totals in inches. And for this, I need to make sure that I leave a space. So this is monthly rain total. And we are measuring this in inches. So I'm going to go ahead and put an I in for inches. So I'm going to put a first dash here that we will label in a minute. And I'll leave that to you guys to do in just after we're done labeling the rest of it. And we have a total of 6 classes. So 1, 2, 3, 4, 5, 6. And then I'm going to put one more dash, and that's where we're going to be extending our graph down to the horizontal line. So the first midpoint that we have is 2.38. The next one that we have is 3.31, 3.13. And I'm just going to go ahead and take all of those that we calculated already and put them in on my graph. And then I'm going to go ahead and circle these just so we don't forget them. And we'll do that at the end. So I need to come up with those numbers. These midpoints are all equally spaced, and we will discuss that shortly. But the first number that we have is 2.38. So at 2.38, we have a frequency of 5. At 3.13, we have a frequency of 11. At 3.88, we have a frequency of 9. 4.63, we have a frequency of 4. 5.38, we have a frequency of 3. And 6.13, we have a frequency of 1. From here, we're going to connect these points with straight lines. And then the next thing that we're going to do with a polygon is we are going to put points at these blank spots that we have. And I'm going to draw down to those points straight lines. Now the next thing I need is those numbers that are going to go in there. And those midpoints that we have on here are equally spaced. And so if you were to look at these, you can subtract to them. And if you did 3.13 minus 2.38, you get 0.75. If you were to do 3.88 minus 3.13, you get 0.75. So we're actually counting by 0.75s. So to figure out that first number, I have to take my 2.38, and I'm going to subtract to that 0.75. And so that first number that we get is going to be 1.63. And then to get the far right number that we need, I'm going to take my 6.13, and I'm going to add up that value, which is 0.75 to it, and I get a value of 6.88. And so we're going to put in, first number would be 1.63. The second number that we have is 6.88. And this is a frequency polygon. And again, for the monthly rain totals that we have, check your axes to make sure that they are labeled and that you have your graph drawn down to the horizontal axes and as starting values at 1.63 and the ending one at 6.88. The next example, we're going to go ahead and circle. We'll work on that one together in class. And we'll talk about what we observe between those two graphs above. The next example that we have says data in the table represents the number of U.S. residents ages 25 to 74 who have earned a bachelor's degree or higher. Construct a relative frequency polygon. So in order to do this, for a polygon, we are going to need our midpoints. And because we're also doing a relative frequency, I'm going to need to calculate those in addition. So first thing that we're going to do, though, is let's find the midpoints. And again, to find midpoints, we're going to take our lower bound and our upper bound and add those together and divide by 2. So adding up 25 and 34, dividing by 2, we get 29.5. And then to get the relative frequency for this first class, I'm going to make another column, and I'm going to divide my frequency, which is the total number that we have, which is 12,967. And yes, that's in thousands, but we'll just leave that part off for right now, and divide it by the total. So we need to add up our total frequencies. So if you add up that column, you get a total of 54,817. So that first relative frequency that we have, you're going to divide the 12,967 divided by 54,817. We're just going to round 2 decimal places because it's difficult to graph anything more than that, and we get 0.24. We're going to continue to do this and get the midpoints by adding our lower and upper bounds, dividing by 2, and calculating the relative frequency that goes along with that midpoint. Once you found all your midpoints and your relative frequencies, you want to check to make sure that relative frequency adds up to 1 or close to 1, and this one does. And then from here, we're going to make our relative frequency polygon. So drawing a vertical axis and a horizontal axis. And our vertical axis this time is going to be not just frequencies, but relative frequencies. And the values that we have for those relative frequencies go from 0.08 up to 0.25. So I'm going to count by 0.05. So 0.05, 0.10, 0.15, 0.20, and then 0.25. So going ahead and labeling all these. And then we're going to go ahead and look at the horizontal axes also. The horizontal, again, is going to be our midpoints. This time the midpoint value that we're talking about is age. And so for polygons, we always start at some value that we'll leave blank. And then we have a total of 5 classes in here. So 1, 2, 3, 4, and 5. And then again, that last value that we'll add in at the end. I'm going to go ahead and put the midpoints that we have down. So we have 29.5, 39.5, 49.5, 59.5, and 69.5. Again, those starting values and ending values, we'll put those numbers in later. From here, I'm going to make points that we have that correspond to the midpoint and the relative frequency. So at 29.5, we have a value of 0.24. 39.5, we have a value, relative frequency value of 0.25. 49.5, 0.24. 59.5, it's 0.19. 69.5, it's 0.08. And again, with polygons, we connect those points using straight lines. And from these last points that we have, we're going to put our points on the horizontal and connect those with straight lines. And now to calculate the values that we need to have to put in the beginning and the end of our polygon, we need to look at how we are counting for our midpoints, and we're counting by 10. So to go from 29.5 to 39.5, it's by adding 10, or we can do what we did in the previous example and do 39.5 minus 29.5 and obtain 10. So to get my first value, I need to subtract 10 from 29.5 and I get 19.5. And then adding 10 in the other direction and get 79.5. So the graph that we have here is our relative frequency polygon. Again, double check to make sure that you have your axes labeled and that the beginning and the end of the graph are drawn down to the horizontal line with those values also labeled. So graphs may be misleading, and the most common misrepresentation of data involves the scale of the graph, an inconsistent scale, or a misplaced origin. So the first example we have is the graph below shows how the increase in home prices from 1998 to 1989. How is the first graph misleading? So if you look at the first graph, you'll notice that it looks like there's quite a big jump between 1998 and 1999 in that 1 year. However, if you look at the values, it's just going from slightly under 81,000 to just slightly above 82,000. So it's not a huge increase, but the way that they have that graph drawn does make it look like it's a bigger increase. The second graph, same data, kind of allows you guys to see that it really isn't that big of a graph change that we would have in scope to the actual price. And the reason why this is misleading is that that first graph is starting at probably like 79,000, whereas the second graph starts at 0. But these graphs you will see in magazines and newspapers and different articles, and they're done this way to maybe portray something that a certain group or political affiliation is trying to portray. This maybe is a realtor just trying to scare people into investing in and buying a home, where it's really not as big of a change of difference there. The next example that we have says the following graph represents the increase in trash production in the U.S. from 1960 to 2000. Does the graph accurately represent the data? And if you look at this, the way that we are taught to do bar graphs and histograms is always that width that we have needs to be equal. But if you notice, the widths on those trash cans is increasing along with the height. So it actually looks like it's increasing a lot more than what it really is. And so there's an explanation already typed there for you guys. This one says the trash can use in the picture grows two-dimensional, exaggerating the growth rate. The data grows by about the same amount from 1960 to 1980 as it does from 1980 to 2000. However, the picture appears to have a much larger increase from 1980 to 2000 due to the size of that can growing two-dimensionally. So be careful when you guys are looking at any kind of graph or table to look and see if it's misleading. Also look at the source to see if it's a reliable source, and don't be deceived by certain things.